Hello, today we are discussing section 1.1, solving simple equations. Our objective for today's lesson is to solve linear equations, using addition, subtraction, multiplication, and division. And then we're going to use some linear equations to solve real life problems, but we're actually going to save these for the end. We're actually going to lump all of 1.1 to 1.3 problem solving to after we get done with 1.3. Okay. So we're going to wait on this step. Okay. So first we need to talk about what is an equation. An equation is a statement that two expressions are equal. So we have two expressions. So again, be filling in your notes as I fill mine in, so everything I write down, you should write down as well. So an equation is a statement that two expressions are equal. So an expression here, an expression is basically just a math phrase. Okay, it's not a complete sentence, it's just a small thought. For example, some common expressions, 6x plus 4. That's an expression. 15. That's an expression. Okay, so it could have a variable, it might not have a variable. Okay, but one thing to notice is these two by themselves are an expression. But as soon as I put an equal sign in the middle, it now becomes an equation. So the equal sign there is what makes it an equation. And the word equation even has the word equal almost in it. Okay, so an equation is a statement that two expressions are equal. Okay, this is what we call, this one here is what we call an open. This one is open because it has a variable in it. It has this unknown idea. There's that unknown thing, that x. Okay, so that's an open equation, but an equation doesn't necessarily have to be open. It doesn't have to have an x. If I said 16 plus 4 equals 10 plus 10. Okay, so in this we've got 16 plus 4, that's 20, and 10 plus 10 is 20, but it's closed. There's no missing piece in here. These two sides, yes, are equal, but there's no missing piece, nothing to solve. Okay, so an equation we can use a descriptive word in front of the word equation, the word linear. So there we're going to use, let's go ahead and highlight that word linear. It's kind of an important word there, linear. An equation is said to be linear in one variable. Again, a variable, if you don't remember, a variable is our letters, our unknowns, our x, our m, a, okay. Those are our unknowns. Our unknown is that variable. But an equation is linear. An equation here is linear if it can be written in the form ax plus b equals 0, where A and B are constants. Let's change that and just say A and B are numbers. Oh, sorry, got rid of that. A and B are numbers. Okay. So A and B are our numbers. Our x in this case is our variable. So one thing to notice is that x right there, doesn't have an exponent. Well, the exponent on it is 1. Okay, so I can't have, so things that aren't linear, x squared, not linear. 1 over x, that also is not linear. Okay, but things that look like 6x plus 5 equals 0, that's linear. Or even 1/2 x plus 3/4 equals negative 2/3 is linear. Okay, equals 0. Well, I could add that over, but we'll just go ahead and set it equal to 0 because that's kind of how we stated it. Okay, but one of these could be negative. It's all right. It's still a linear equation. The fact that you have just a straight up x with no exponent is what makes it linear. Okay, so now solution, if you remember, the solution of an equation is a value that makes the equation true. Okay, so solution is really the missing piece. So the solution is the missing piece of the math sentence, okay? Up here, we talked about an expression being a math phrase. If an expression is a math phrase, then the equation is a math sentence. And once you fill in that missing piece, you can fill in the rest of that sentence. So for example, let's go ahead and let's start with a simpler one. X plus 4 equals 2. Okay, so this is linear because I could take this 2 and do some magic to it, move it to the other side. We'll talk about that in a minute. But if I'm looking for what X makes this statement true, what plus 4 equals 2, well, that would be negative 2. So if X was equal to negative 2, then that would work in there. So if we replace the X with a negative 2 plus 4 is 2. So this is, in fact, a solution. That is a solution to this equation. Okay. Okay. So to help us find solutions, we're going to use something called inverse operations. Inverse operations are two operations that undo each other. Okay, so basically they undo each other and get us back to where we started. So if I start with the number 10, and let's go ahead and let's add 6 to that. That gives us 16. If I take this 16 and now subtract 6, that gets me back to the 10 that I started. So the adding the 6 and the subtracting 6 undid each other, so we call them inverse operations. Add and subtract are inverse operations, and so are multiply and divide. Okay. So equivalent equations, equivalent is just a fancy word for saying equal. Equivalent equations here is just a fancy word for saying equal. Equivalent equations are equations that have the same solutions. Okay. So I'm going to go up and come up with a bunch of equivalent equations. 2x equals 10. Okay. 10 minus x equals 5. Okay. 50 divided by x equals 10. Okay. So if you notice, the solution to all of these is 5. 2 times 5 is 10. 10 minus 5 is 5. 50 divided by 5 is 10. So these are, all three of these are equivalent equations. All of these are equivalent equations. And as long as you have an equation whose solution is x equals 5, it would be equivalent. Now it's important to note that only 2 of these are linear. These 2 are actually linear. This one is not linear, but it's still an equation, and it can still be included in my equivalent equations. It's just not a linear one. And we'll talk about what that word linear means when we get into graphing. The reason we call a linear has something to do with its graph. Okay, so now we're going to talk about the properties of qualities, the properties of equality. You've used these already in previous math classes when you've solved equations, but we're going to talk about them again. A property of equality is adding, subtracting, multiplying, or dividing each side. That's an important aspect of this. Each side of an equation by the same number produces equivalent equations. And here, this bit in here, sometimes non-zero, that's really just with our divide because you can't divide by 0. So the reason we have this here is because you can't divide by 0. So we don't like using that one over here in the multiply and divide. We don't like using 0 here. So over here, we really say we don't want to multiply or divide by 0. Okay, so basically what this means, okay, what this boils down to is if I have an equation, okay, let's just I'm going to go ahead and give you a true equation. 3 plus 7 equals 10. Now, if I was to take both of these equations, and we call this, an equation has 2 sides. Okay, here's a side, the 3 plus 7, here's the other side, the 10. Now, if I take each of those sides, and let's say I take each side and I add 15. Okay. can I still use an equal sign in between here? Are these two sides still equal? Yes, they are. Because this side, instead of being 10 now, is 25. This side, instead of being 10, is 25, so they're still equal. We really want to think of this as a balance, and the two sides have to always be balanced out. So if you're just introducing and adding 15 to one side, you have to do it to the other. The same holds true for subtraction. If I was to take this, let's go 4 plus 5 equals, and let's do 2 plus 7. Okay, so here we have our two sides, 4 plus 5, well that's 9. 2 plus 7, that's also 9. I can take both of these sides, this 4 plus 5 side, and this 2 plus 7 side, and I can, let's say, subtract 3 from both sides. They're still equal. This side is now equal to 6, but this side is also equal to 6. So they're still equal. So subtracting the same thing, subtracting this minus 3 from both sides kept this thing equal. Okay, the same. So we use these methods to help us get variables by themselves. And I'll show that here in this next example. Okay. So now we have multiplication. Okay. So we can multiply both sides by the same thing. So here if I have, let's go 2 times 5 equals 10. I can take this side and this side, multiply both sides by 4, and it's still equal. Now we have 40 equals 40. And I can do the same thing with division. If I have 6 divided by 3 equals 2. I can take both sides and multiply both sides by 3, and it's still true. Okay. These are still, in fact, still equal. I get on this side, 6 divided by 3 is 2, times 3 is 6, 2 times 3 is 6. So it is still true. Okay. All right, next page. So now we're going to be like, okay, what's the point of this? So now let's go ahead and let's do some examples where we see the point of this. So our goal, example 1, here we want to solve. The directions aren't on here, so I'm going to do it. We want to solve, meaning our end goal, figure out what x is. Figure out what x is. What is x? What number is x? And so to do that, what we're going to do is we're going to get x all by itself. Okay? So whatever operation is there, we're going to do the inverse to get it alone. So right now, first things first, find my x. My x is right there. My x is x. What's happening to that x? Well, right here, we're subtracting 3 from x. So we come over here, we use our idea of inverse operations, and I know the inverse of subtraction is addition. So instead of subtracting 3, we're going to add 3. But I can't just add 3 to any random thing. I have to do it to both sides. So I'm going to take this side, write this side just as is, x minus 3. This side just as is, and now I'm going to add 3 to both sides. So now I'm going to double check. On this side, taking x, subtracting 3 and adding 3, these two, if you remember from subtracting is the same as adding a negative. So these two actually add to 0. So on this side, I'm just left with an x. Don't forget your equal sign. And then on this side, negative 5 plus 3, they're different signs. The 5 is bigger, so I'm going to subtract. Minus 3 is 2, it'll be negative 2. So my x is equal to negative 2. So now that I have a solution, I want to check my work and make sure it works. So I'm going to plug a negative 2 back in there. So here's my check. Negative 2 minus 3 equals negative 5. Okay, so yes, that one did work. Negative 2 plus a negative 3 is negative 5. Okay. All right, now on this one, again, our first step is we want to solve this. We want to figure out where's my variable in here? Well, there it is. What's going on with my y? Well, on the same side of my y is an add 2.8. So I want to get rid of an add. We think back to what's my inverse of add? The inverse of add is subtract. So to get rid of an add 2.8, again, my goal is to get that y by itself. I want to subtract 2.8. So I'm going to flip-flop these sides, which you can do. So I'm going to write y plus 2.8. I'm going to leave a space and then put my 0.9. So there's my two sides yet. So again, here I want to do the opposite of adding 2.8, which would be subtracting 2.8. Same over here, subtracting 2.8. These still equal. So now these here undo each other. So these would give me 0. So the only thing I'm left with on the left side is y. Now I need to figure out what's 0.9 minus 2.8. Okay, so subtracting is the same as adding a negative. So I want to take these and I will subtract them. 1.9, and it would be negative. So y equals negative 1.9. If you're unsure on this guy here, I'm okay using a calculator. Feel free to use a calculator if you need it. Y equals negative 1.9. Okay, so now let's go ahead and we've got this one more example to do. Okay, so example 2, there's 3 of them here. But I think we're only going to do the first 2, and then we'll go ahead and let you try one on your own. Okay, so here we have n negative, we've got a negative there. Don't forget that negative right there. N divided by 5. So if you remember from previous classes, this negative can go on the n or can go on the 5. I'm going to rewrite it like this way. It's n divided by negative 5. Let's leave a space, equals negative 3. So I'm taking n here, and I'm dividing it by negative 5. This is just, do not let fractions freak you out. This is just a divide sign, okay? But I'd really like you to don't use this symbol. Okay, we want to get used to that fraction bar, but it is just a divide sign. And the inverse of divide is multiply. Multiply and divide are inverses. So to undo a divide, I'm going to multiply. So I'm going to take this side and multiply by the negative 5. And take this side and multiply by a negative 5. So dividing by a negative 5 and multiplying by a negative 5, these undo each other. Or you can think of it as I'm going to have negative 5 divided by negative 5, which is 1. So I'll have n times 1. Well, n times 1 is just n. That's really what's happening there, this process. This is really what's happening there, except I forgot my n out here, n times. Okay, and on this other side, we just have negative 3 times negative 5. We just multiply. The signs are the same, so it's going to be positive. A negative times a negative is positive, so n equals 15. And then if you're not sure, we always want to check our work just to make sure. If n is 15, if n is a 15 up here, we'd have negative 15 divided by 5. And that does, in fact, equal negative 3. All right, next one. Okay, so now we have pi x equals negative 2 pi. So on this guy, hey, we don't want this pi to freak us out. This pi is just a number. Pi is just a number, people. This is a number that's approximately slightly bigger than 4. It's approximately, oh, those are horrible approximately signs, Ms. Neal. Approximately 3.14. Just slightly bigger than 3, ... It keeps going for forever. But if I have those, I just think of this as a multiply. So sidebar, how I would think of this is it's like 3x equals negative 2 times 3-ish. So to get rid of this 3 times, there's actually a times going on there, and it helps to write that in. To undo a multiply, I would need to divide. So I would need to take this side and the other side and divide both sides, we're going to use fraction bars, by what's multiplied by the x. Well, the thing multiplied by the x here is the pi. So we're going to have to divide both sides by pi. Okay. Well, pi divided by pi divided by pi here is just 1. So on this side, I'm left with an x equals. Same on this side, I've got negative 2 pi divided by pi, which that is also a 1. So on that side, I have a negative 2. So x equals negative 2. Okay. Now this one I think you can do on your own. Okay. And so now for you to practice this skill, I want you to do page 8, problems 2 through 14 even. 18 through 40 even. Problems 50, 52, and then 58 through 61. Again, remember, proper practice, write the problem down. And show your work. Again, you will be redoing it if you don't write the problem down and do not show adequate work. So, it's easiest if you just do it the first time. So, and the directions right here. Do all work on a separate piece of notebook paper. Make sure it has a proper heading. Heading should have your name, the section number, it's 1.1, page and problem numbers. When finished, you're going to correct it with the provided answer key. I will post the answer key on the website. Highlighting the ones you get correct. You're going to highlight the ones you get right. Figure out any mistakes that you made and correct them. Once you have the entire practice fixed, you're going to check it with me, or if there's a parent in the room, you can check it with them, and then you will take the short quiz. Okay, best of luck.